So today we're going to learn Mesomeric effect within 10 minutes. So actually Mesomeric effect, also known as resonance effect, it is a very important effect because it is the second strongest effect of GOC, and it is more important than inductive effect, which we have covered yesterday. But the thing is, at meta position, it is powerless. It unable to show any effect. But other than this meta position, it is the dominating one. Okay, so means the order of this is much more important than this, although it is more important only when we are talking about meta position. So here it is. So in mesomer effect, there is not the shifting, there is the complete transfer or delocalization of pi electrons. Remember yesterday what I said? Here the sigma electron shifting, not pi electron, but here it is. Here the delocalization of pi electrons, not sigma electrons. Okay. So similarity with eye effect. What is the similarity of it with the eye effect? It is the similarity is that the electrons here also go towards the more electronegative atom. Means the transfer or the delocalization of pi electrons is toward the also happen toward the more electronegative atom. Okay, but there is the point of difference that it is not distance dependent. It is not distance dependent. It is distance independent. Means it can be as long as the but there is some condition at which it's depend also, which decide up to which extent it will be seen. So here it is the two such condition which is required for such for it for this effect. That is first, actually these both are conjugation conditions. So here it is the first alternate double pi bond, and okay, alternate pi bonds condition, and the second one is one pi bond, and here it can be here can be a carbocation or a negative charge or a free radical or a lone pair. So any of it can be present here to and show resonance like this. If the group is more electronegative atom than carbon, the electron will transfer toward it, and it will it is known as minus I minus m effect. And if the group is not more electronegative than carbon, the electron will transfer toward carbon chain, and it is called plus m effect. Is this just similar as like the plus I, plus I or plus m, as we have already learned here? So just like that, m is telling what he want. M want to be negative means it will take electron from the carbon chain. M want to be positive means m positive means it will give the electron to the carbon chain and become positive itself. As just like that you can learn this. This is one of my trick also. Now here what is the advice I will give you is that here the most important order from this which you will see in questions more often is plus m effect. But if you learn this one, which is a little easier and less than this effect, then the rest will automatically you can guess into the plus m effect. So in minus m effect you can see this is NO2, then NO2 more than Cn negative, more than COOH, I mean NO2 mean nitro, more than cyanide group, more than aldehyde group, more than ketone group, more than anhydride group, more than carboxylate group, more than carboxylic acid group, more than amide group. Okay, so this is very simple. If you and it will be you will be remember easily. Just try to remember this, and the rest will you can guess it in plus m effect. Okay, that's how you can learn this easily. Here we can see that here is the N negative H more than O2 negative, more than NS2, more than NHR, more than NR2, more than OH on ORC. Here it is. It just come after this nitrogen family related group. Here OH over, whereas in I effect you can see it is little, it is here. It is after halogen. Here is minus I effect, and here is plus M effect. One thing you notice that the group inside in plus M effect are seen in minus I effect. Now here come here again. So OH more than OR more than NHCOR more than OOC OCOOR more than pH means phenyl more than halogen, fluorine more than chlorine more than bromine more than iodine more than nitro NO. Okay, so that's how you can learn this. And thank you. And one more thing I want to tell, that mesomeric effect is sometimes also known as sometimes we use R effect. We used to call it R effect, or we commonly call this resonance effect. But there is a little difference between them. That is that the resonance effect can be a mesomeric effect, but every mesomeric sorry I'm sorry for this mesomeric effect, actually resonance effect contain mesomeric effect. It is a type of resonance effect. So mesomeric effect when this situation here, see, when this situation occur where the resonance because of any carbon cation, yeah, or negative charge or free radical or lone pair, then this resonance we usually say this mesomeric effect. Okay, so it's not so much difference, it's just a little bit difference. You can use mesomeric effect or resonance effect as without any kind of hesitation. And that's it. Hope you like it, and remember this one. The rest one, or you can guess it into this plus m effect, and according to this you can solve your questions. Thank you. And if you are scrolling, stop scrolling now and go to study. Bye.